Okay, hello everyone. We will continue in part 2 to answer the second part of the problem, which is to show that the Fourier transform of yt, a convolution process between xt and ht, equals the multiplication of the Fourier transform of h with the Fourier transform of x. Okay? So to answer this question, what we do is first, based on the answer that we've obtained above on our yt, okay, so now we need to find what is the Fourier transform of yt. Okay? So find yj omega, which is the Fourier transform of yt. So looking at your textbook, what is the Fourier transform formula? Which is y of t multiplied with e minus j omega t, and then you have the integration, right, from minus infinity to positive infinity. So based on our y of t, we see there are three parts of yt. When t is less than 1, it's equal to 0. When t is between 1 and 5, we have a function of 1 minus e to the power of minus t minus 1. And when t is bigger than 5, we have this expression for our yt. Okay? So what we do is we do it parts by parts. Okay, we look at what is the value of yt when t is between 1 and 5, and then find what is our Fourier transform of this expression. Okay? So just using this formula, so we just insert the time, which is between 1 and 5. Okay, following this, right, and then the expression of yt here multiplied by e minus j omega t and integrate it. Okay, so the solution of this integration and filling up the limit value of t equals to 1 as well as t equals to 5, we end up with this expression. Okay. Next, we look for the y of j omega when t is bigger than 5. So we have this expression, okay, for our yt, right? So we use this as our yt multiplied by e minus j omega. Okay, so this and this, right? So it becomes a problem of solving this integral with these limit values. Okay, so we are left with this as our solution. Okay, so now we consolidate both the expression of our yj omega, this and this. Okay, and finally combining them together, simplifying it, right, we obtain this. All right, so the question is yj omega equal to hj omega multiplied by xj omega? So to answer this, is it equal or not, we need to find out what is the multiplication of hj omega with xj omega. So let's look at what is xj omega. Okay, so xj omega, of course, is the Fourier transform of our x of t, which is this from the question, right? So how do we find the Fourier transform of this? So one way is we can use the table of Fourier transform as well as the properties of Fourier transform to find this value of xj omega. So let's look at this approach where we look at this as a as a we have this xt, for example, x1t, okay, as a manipulation of this to find this. Okay, so from the textbook, okay, if I bring you to this, look at the Fourier transform table, there is one entry for e minus at multiplied by u of t. Okay, so we see that we can use this to answer our problem here. Okay, this a is 1, right? So xj omega becomes 1 divided by 1 plus j omega. Okay, and then if we look at our x of t, this is if we refer to x1t, it's actually x1t shifted to the right with 2. Okay, so with that we can use our Fourier transform table properties, right? So if you look back at your textbook, there is a table for Fourier transform properties, and look at the time shifting here, okay, whereby if you have a time shift of t naught minus t naught, then you can just need to multiply with e minus j omega t naught with the xj omega of this x of t here. Okay, so with that, we can find our xj omega. Okay, so x1t, we define it to be this. From the table, we have this as our Fourier transform. And then we find our expression of xt in terms of x1. Okay, and then we use our x1j omega to find our xj omega, where our xj omega is actually, this e to the power of minus j2 omega. 2 comes from here, okay, and then multiplied with x1j omega. Okay, that's the property of a time shift, right? So we're done with xj omega. What about our hj omega? Okay. So what is our h of t? H of t is this pulse, right? And from our Fourier transform table, we see there is an entry where if h1t is defined as this, right? Then we can find our hj omega to be given as follows. Okay, this is from the table. I'll show you here. This is the Fourier transform properties, and below you here you have, okay, for this is your pulse, okay, 1, and then between t minus t1 to t1 and 0 beyond t1. So you have this as your Fourier transform, okay. And then if you refer to the question again, so if this is our t naught, this becomes this. So how do I redraw this from here? Okay, so one step is, if I shift this to the center of the y-axis, right, so that it becomes at the center, it will be at minus 2 and 2, right? Okay, so if this is our h1t, then our h1j omega becomes this. Okay, our t naught is 2, which is shown here, right? Okay, and then from h1t, can we find our h of t? Okay, we found that ht is actually h1 shifted to the right by 1. Okay, so once we have this, okay, we see that we can also use our Fourier transform properties to find what is our hj omega. Okay, the hj omega becomes similar to just now. If you look back at the property table here, okay, for the time shifting this. Okay, so what is our t naught? We have it multiplied here with our xj omega. Okay, so this is our t naught here is 1. Okay, and then it's represented here multiplied by the h1 j omega, which is this. All right, so now since we have our hj omega as well as xj omega, we can form the multiplication. Okay, so this is my hj omega, this is my xj omega, multiply them together, this is what we get, right? So now is this h multiplication of h and x equal to our just now what we obtained our yj omega? Is it the same? Okay, so we see that in our x and h multiplication, there is a sign function here. So what we can use is we can convert this into exponential using the Euler. Okay, so let's convert 2 omega divided by omega into exponential using Euler's relation. We have this. Okay, this is equal to this. Okay, now we replace this inside here, okay, where the sign function is, right? And then we can now find it to be equal to this by simplifying the above. Okay, now this is actually equal to yj omega. So here we've proven that indeed the from the question that is verify the convolution property for this pair of signals by showing that the Fourier transform of yt equals hj omega and xj omega. So that's done by following the steps I've mentioned before. Okay, thank you.